Okay, something that we didn't get to today are the last remaining questions. And again, I assigned these for homework tonight. I just wanted to look at one of them, let's say question number 12. First of all, notice above question 10 it says for questions 10 to 13, round your answers to the nearest degree. Rounding your answers requires the use of a calculator. Okay, that's where we're going to put a calculator into place. We do not need our special triangles. Okay, so our calculator is required. Determine two angles between 0 and 360 that have a cotangent of -3. Another way to word the problem, of course, is to find an angle where the cotan of that angle is -3. Well, cotan has reciprocal, or it is a reciprocal trig ratio of tangent. So the tangent of theta must be the reciprocal of this number, and of course there's an invisible 1 underneath. So the reciprocal of -3/1 is 1/3, or just -1/3. We know how to find an angle using sine, cos, and tan because those are the numbers that are on our calculator, or the buttons that are on our calculator. So we simply just have to press tan to the -1, and in this case maybe we'll just do -1 divided by 3 and come up with an answer. Tan to the -1, of course, over top of each of our trig buttons, we have the sine of the -1, cos of the -1, tan of the -1. Those are the buttons that we push when we're trying to find an angle measurement. Okay, so I have -1 divided by 3 and tan to the -1. I have an older style calculator here, so I actually have to put in the ratio first. Okay, so I'm going to put in -1, or 1 negative, divided by 3. Of course, I already knew that that was -0.333. And now shift tan gives me this angle. Okay, so for here, then I have an angle of -18.4 degrees. But I notice in my textbook it says round to the nearest degree, so I go back to this, and I'm looking at then approximately -18 degrees. Okay. My calculator is giving me a negative answer. We don't want negative answers. Negative degrees are angles that run clockwise on our Cartesian plane. So -18 degrees is this angle here. We always want to have an angle in standard position. So the angle in standard position is this one. Okay? And that would be the result of the difference between 360 degrees all the way around, take away 18. That angle in standard position then would be 342 degrees. So our angle in standard position is 342 degrees. Notice we're in the cosine quadrant where the tan ratio is negative. Only the cosine ratio is positive. Okay, so 342 degrees is a good answer here. So, in fact, we want an answer for theta to be 342 degrees, not -18 degrees, because that's not in standard position. The only information that gives us is an acute angle with the x-axis. Our calculator will always give us the shortest terminal arm distance from the positive x-axis. That's what it'll spit out. Now, there's another quadrant where tan is negative, and that's up in this quadrant here. Notice the distance between this positive x-axis and this terminal arm is longer than the distance from the positive x-axis to this terminal arm. And that's why our calculator gave us this answer. It gives us the shortest distance. Even though we don't want a negative answer, the calculator doesn't know that. Okay, so what we're looking at now then is the angle in standard position. Well, we know that this acute angle is the same as this one, 18 degrees. So this angle in standard position is going to be the result of 180 subtract 18 degrees, which is 162 degrees. So two angles, as it says in the question, determine two angles between 0 and 360 that have a cotangent of -3. Notice how I avoided the cotangent altogether. I turned it into something that I'm familiar with, tangent. Something that I can use my calculator with, tangent. I don't have a cotan button on my calculator. Okay, so I've just simply made a quick conversion to a primary trig ratio, used my calculator to get an acute angle, made sense of it on my Cartesian plane in terms of an acute angle on here, used my cast rule. Okay, I didn't write the whole cast rule out, but we know that only sine is positive in this quadrant, so tan has to be negative. And we have our two angles. We have angle 1, or theta 1, and we have theta 2 being 162 degrees. Okay, so I could double check that just to make sure that I'm correct. 162 degrees, and if I press tan, that's the same as tan of 162 degrees, I get negative 0.3, 249. So I rounded, but my answer should be negative 0.333333, right? But because I've done a little bit of rounding here, I went down to the nearest degree. I'm getting very close to the negative 0.3333, okay? But I, in fact, because I rounded, got negative 0.32. But that's a good way to check your answer to make sure, okay, am I in the right quadrant with the 162? Yes, I am. My calculator tells me I'm very close, and the rounding is what led me astray there. Okay?